calculate my script, the entire geometry will be updated. Some additional purlins will be added. The loads will be recalculated and reassigned. So right now you can see, the values of loads have been, automatically updated, reflecting to the geometrical changes. That's the beauty and the power of using that, automated workflow for analytical modeling. Let's go back. Let's rerun. And the last thing is I wanted to highlight in this workflow is the process of running calculations and exploration of results. So we have this node gives you the ability to run calculations from within Dynamo. And as an input, we need to provide the analytical model definition, the entire analytical model definition. In other words, all members. So my first item here, let me unfreeze this. So the first item in this list is a list of all analytical members, 142 of them, as an output of the node where I was setting up, my material for my structure. And the other two items are load cases, those two load cases that are taken into account during calculations. So let's run it. And let's, before I do this, okay, let's run it. I started the script. So you should see in a second that my project, did I run it? Yeah.
Tomasz, while that runs, there's a question in the chat, which is a pretty good one and an interesting one, I think.
Yep.
So Marcelo Scambarelli, sorry for butchering your name, Marcelo, wants to know, so all the functionality is there, but not necessarily all the nodes. So are there any samples of code out there to sort of get a better idea of how to make custom nodes for Dynamo for Robot? Any packages, Python-based maybe, or even open source zero-touch nodes that people could refer to?
Unfortunately, we don't have such examples, but if you are familiar with Python scripting, just go through Python scripting, or you created some zero-touch nodes for Revit to just go explore the robot API documentation and do it in the similar way. The process is pretty much the same. If you don't want to play with zero-touch nodes, then just use Python and do the same. The key is to understand the RSA API and how to the rest is the same as in the Revit case.
All right, thanks. Hopefully, yeah, Marcelo, hopefully that covered everything for you.
Marcelo, reach out to me if you have any detailed question. I can try to answer. If I do not know the answer, then I find the right people. So in the meantime, the structure was calculated, and so we have this notification in the title bar that results are available, and we have now the workflow says that we have two options. We could visualize results in form of diagrams in this case. For specific internal, for specific internal, for specific internal forces for MY moments in RSA, or like I mentioned, we can do the same in Dynamo. So we can retrieve some maximum, minimum values. There is by the way, there is a bunch of nodes to explore results for members. So for bar displacements, for bar forces, bar stresses. And we can also visualize the internal forces in form of diagrams in a similar way as we do in RSA. So let's change the member. I want to explore results, and let's recalculate. There we go. So we've got my moments, internal forces, and FZ forces as well, shift forces. So you can take those numbers, data, and continue developing the logic for code-based design, from this point. So with that, I would like to hand over to Stefan, who will walk you through Dynamo and Advanced Deal. Thank you.
Awesome. Can you hear me? Can you see my screen?
Yes. Yes, we can.
Awesome. Okay. Yes, welcome. So thanks for that great introduction. I learned something new myself there. It was good. It's always good to see somebody else doing something different to what you're used to doing, because there's always something new to learn, right? So from my perspective, we're going to look at Dynamo with Advanced Steel, but we're going to look at it from more of a fabrication piece. Obviously, Advanced Steel's bread and butter is fabrication. So looking at the fabrication piece, I always say it's taking those next steps to automation with the 3 M's. And it's a bit gimmicky, but it's a way to describe what we're talking about. And my mantra, and has been for many, many, many years, is I want to work smarter, not harder. And so hence why I've got the techie background, the programming aspect, and of course the Dynamo side of things. So what do I mean by the 3 M's? Well, we're talking about make, modify, and metadata. And by this, we're talking about obviously the creation of objects, manipulation and modification of objects, and how to utilize data that sits inside of these objects to help do whatever it is that I need to do. As I said, it's more focused around the fabrication piece. And with fabrication, there's obviously a lot more information that needs to be stored in these objects. There's checking that needs to be done during the creation process, which, again, Dynamo can facilitate the ability to create rules to go and check certain things during those modeling phases. So, I mean, the big question people always ask is, why would I even explore Dynamo, right? Why? Or why automation in general? And I mean, the obvious two for me are efficiencies and, of course, the removal of those human errors. And until someone actually gets involved in automation, people don't actually understand the amount of time saving that can be done when it comes to automation, especially, using Dynamo. I think that the reason Dynamo is such a great tool in all of our products is it's that in-between piece for those non-programming individuals. So, I might be a draftsman, I might be an engineer, but I might not have programming background. But from a logic perspective, I can string logic together, right? So for me, it's that go-to space for those people who don't want to learn how to write code, but want to take their design or their modeling to that next phase. Of course, as Tomek showed, you definitely can still include this in your processes, and the nodes can be extended, of course, as well. So if we look at all the Dynamo nodes that exist inside of Advanced Steel today. I think we're topping at about 200 nodes. So quite extensive. They're all posted on GitHub. It is an open source package. So if you were looking to extend and write your own nodes, the ability is there to go and create your own nodes as well. If we look at the make side of things, it's obviously, or if we look back at the 3 M's, make means creation of those basic advanced steel objects, the beams, the plates, the grating, whatever they may be. The creation of modification, as in holes, cuts, etc. Or the creation of supporting objects like grids or cameras. So there's lots of different options in that space. If we look at the modification side of things, or modify, being able to select the objects, use utilities to I guess modify those objects, edit the properties of those objects, which obviously leads us onto the metadata side of things, because metadata is actually part of most of these processes. But for me, the big standout one, and we'll talk about this a little bit more, is about how to use that metadata to, I guess, take it to that next level, or take it to another file format. And I'll show you what I mean. So what I've actually done is I've flipped my slides on their head, and I start with metadata. And there's a reason for that. So when we talk about the data that exists in our objects themselves, we want to add data, we want to import or inject data, maybe change existing parameters or properties of objects, or, and this is the big one, set properties during the creation. And ultimately, as I said, the extraction of data. How many times do I get questions from customers, and there's heaps? I want to export a certain type of XML file, a new format of a CSV. I've got a specific fabrication machine, just needs a basic CSV file. How can I do that? And this should give you the ability to do that, right? So the data component is massive, right? If we think about the properties that exist inside of Advanced Steel, there is a property object or property node for every object type, right? So the thing to look out for is this specific object type and properties type node, and it exists throughout the tree. And when you get this tree, you get this, once you select this node, you get this node that comes up with the drop-down list with all the different properties that exist as part of that object itself. So for example, having text-based nodes or number-based nodes, say for example, decimals. So in this case, the length of a plate. Or if we look at integers, looking at the explicit quantity of an object. Maybe even extracting points. So being able to extract the center point of the plate, or the coordinate system of that definition of that plate. So now we're looking more into the properties once the object's been created, or when I've selected a specific object and I want to do something with it, right? And of course the plane where that plate might be defined. Now, when you look at the last three, they're inputs into the creation of new objects as well. So being able to extract information out of old or existing objects and reuse that data to create new objects, I think is also handy. And this is the reason why I put metadata first when describing the 3 M's. Ultimately, it's using a combination of those properties and selection nodes to be able to manipulate either existing objects or, as I said, create new objects, right? So you can see there's a bunch of property nodes where you can get a property by name or value, set or get properties. Some properties are read-only. This is not documented, unfortunately, but you'll get to learn them over time. If you get stuck again, ping me if you need some help. So if we look at the make side of things, and this will show a little bit more on what I mean when it comes to those properties. So, being able to create beams, plates, and you'll notice here the plate properties snippet where I took it before, gratings, and you can see bar grating, standard grating, variable grating. And I didn't expand these out because the graphic would have just gotten too long, if you like, right? But you can see for each of the types of nodes, like plates, for example, there's multiple variations, as in or multiple options on how you might create those. So here you can see rectangular by coordinate system. So I'm extracting that polygon from that other object and the coordinate system and combining those two and to be able to make new objects themselves. The concrete elements can be modeled through Dynamo, and miscellaneous objects, so grids, cameras, special parts, can all be modeled using Dynamo or manipulated and modified, right? So you'll see some of these objects, for example, have a series of modification functions that exist as well. So for example, setting the XY extents on a camera or manipulating that existing camera accordingly. So examples of where I would use make, anywhere where we have repetition, right? Stairs, trusses, frames, chutes, bins, hoppers, plate work in general. This is all very detailed screenshots you see here, but the example that you see here is item 1 and item 2 are identical in that they are the same type of truss that's created in a conveyor from one to the next to the next. The difference is this might be a 12 meter truss and this might be an 18 meter truss. So therefore using that Dynamo ability to create repetition, but it's just shorter or a little bit longer or whatever to give us that automation piece. Now, where does the metadata come into play in the creation of objects? Well, each object has an option parameters, and you can pass these additional parameters that we talked about in the metadata as a list to the creation of these objects. So rather than extend, and I did originally when we started extending these nodes, we started making nodes with masses of lists of parameters all in the node itself. But what we've quickly looked at, the amount of properties that actually can be passed to these objects during the creation phase, the amount of nodes we would end up having to create and maintain would just be not usable. So what we did was we created the ability to create these additional parameters that can be passed to each one of the basic nodes to allow you to pass almost an unlimited amount of parameters to those objects during creation. So whether it was a straight beam by line, a poly beam by a poly curve, a plate by a polygon, doesn't matter. All of them have the option to provide extra parameters. So you can see here I've created a bunch of parameters and then passed it to the create instance of that node to be able to pass extra parameters to that object. So if we look at it in this example here, so technically in this case we're actually passing 3 extra parameters to the creation node itself. So in the first instance here, we're passing the name and the type of the object, right? So you can see we're taking the equal angle type, the size of that, passing it here to the create section string node. We're saying that we want to create the profile name property and then combining the output from this node and this property name as a property and then passing it as the first entry point to this list. And then if we go to the next one, we're creating the model role. Again, we're selecting the type of property from the drop-down list, passing it as the property name, the value that needs to be stored as part of that property, and adding it to the list, and so on and so forth. So you can see, and in this case, material itself. So you can see the amount of properties you can pass on creation of these objects. It's not unlimited because there is a limited list, but technically it's up to you on how much you want to automate as part of this process. And as I said, at the end, we put this into a list itself. Why? Because this list actually has to be passed as a list, or all those properties need to be passed as a list to that creation node. Hopefully that makes sense. And you can sort of see now why I put the metadata side of things at the beginning. And originally when I had my slides created, I had it in the same order that I started with. But yeah, and we'll follow on to the modify side of things.
We got about 2 minutes left before we have to start wrapping up, unfortunately. I think we might set something up to maybe have you back to go over some of this other stuff, because this is really good.
Sure, definitely. So from a modification perspective, obviously cuts, copes, holes, polycuts, anchor patterns, shear studs. I mean, there is so many things. And again, you notice here, anchor bolt properties, right? There's lots of options here, right? Grating, concrete elements, modifications of those elements, and then, whatever that might be, am I adding an extra hole to every beam that I've selected 35 millimeters in from each end, right? Or 1 inch, if we want to talk imperial. Am I changing the material grade of all the objects that don't meet a certain criteria of a property, right? Or am I adding in a text value into one of these areas, right? So I did, was going to go into a live demo. Do you think maybe we should pause there and?
Yeah, I think that's probably a good stop point. And I will quickly take over the screen share.
I'm happy to come back and do a bigger, deeper dive if you like, because there's plenty to show and talk about for sure, especially with 200 plus nodes sitting in that space. Yep. It's not exactly a 5-minute discussion.
No, definitely not. So I did want to touch on a couple of questions that we had pop up in the chat. The first one was from Edwin, who asked, is there any plans in the future to integrate optimization options, like optimizing the form and members based on the loads and boundary conditions? And Edwin, that's a great question, and you might want to attend, and Tomasz, I'm going to let you weigh in on this too, but you might want to attend the coming sessions on generative design, because there are ways that you can start to hack those two pieces together and get them to work. So Tomasz, do you have any further color commentary there?
There are no specific plans on RSA side, to extend, this package functionality. So it's not on the roadmap when it comes to, pure RSA. Yeah.
Okay. And then there were some other questions on the advanced steel side in terms of how to make particular plate types and shapes like that. Stefan, to your point, 200 nodes.
Unfortunately, no, not yet. So the folded plate option was one that was originally on the list, but those 180 nodes that we added that year, time just ran out, and unfortunately there is a deadline for these code to be written, so currently not. But look, who knows what the future holds. But yeah, also happy to do, John's asked if we could do a dedicated session to advanced steel. More than happy to.
I've already got a note to talk to Sol about that and see if we can get something set up in our current roadmap for sessions we've got planned. So we'll be in touch, and we'll make sure to circulate that out to you, John, and others to the larger community conversations marketing machine, for lack of a better term. All right, so on that note, what is coming next? So we meet every 2 weeks, Thursday at 1 p.m. Eastern on the East Coast of the U.S. If you're elsewhere in the world, hopefully you can go ahead and do those conversions, and it's not super, super late for you like it is for Stefan at the moment, but there we have it. Now, we do have a summer break coming for the month of July. Sol and I just both want to go out and see the outside and have some fun, so we're going to do that. But we'll be back in August talking about Dynamo's visual refresh, all the changes that have come in Dynamo 2.13 and some of the things to keep in mind there. We've also got coming up after that, we're going to be diving into into generative design, starting with a special guest, John Pearson from Parallax team, who's a very active member of the Dynamo community, so really excited for that. And then picking up from there on September 1st, and then again on the 15th, but it's not written down yet, with Lily Smith to talk about from the generative design team, actually, to get a little bit more deeper into sort of the authoring of the tool sets and stuff like that. And then many, many more awesome things to come. Sean, over to you.
Thank you, Jacob, and thank you, Stefan and Thomas. That was awesome. There's a lot of deep stuff in there. I mean, back in my history, I've done some structural. I've also done some bamboo structural analysis, so it was always fun. But it's neat to see how you're able to automate it. Some of those simulations. I want to quickly go over, we got some resources for you, some community resources. Also to mention that when you exit here, there's a quick little survey, and I do mean quick. It helps us figure out what we should do in the future, what we're doing right, how we can improve, all those good things. But it's really quick, and it does help us. So I have pasted a link. The recording will be on the event page as well as YouTube. And I'm going to give you some links, and I'll put them on the event page as well for community resources. Many ways to explore and connect in the Autodesk community, including the global network of user groups, the industry-focused communities helping your colleagues solve business challenges together, forums, Twitter, all kinds of good stuff. The Voices blog, which is customers. Anybody who has any kind of expertise in Autodesk products or industries is welcome to become an author on that. You can also become a community conversation presenter. So if you'd like to lead a really special that you or an industry or a talk, please feel free to reach out to me. There's also a link I put into the chat there on a forum. So many resources, but thank you so much for joining us today. And this is, like Jacob said, the last of the month, and then we got the month break. So I'm going to take a few days off. Yeah, maybe I'll probably just end up outside, but also playing with the AI again, Jake, to be honest.
I knew that was coming, Sean.
Yeah, I'm going to make, what happens if I put marshmallows with fungus and spiders? That kind of stuff. It's just interesting to see. But thank you, everybody. We hope to see you again. There's a lot of new sessions on the calendar. If you look at the event page for community conversations for August, September, and October, and we'll be adding more and more as we go through the month of July, plus some replays of some greatest hits. So thank you.
Awesome. All right. Thanks, everybody. And thanks, Tomasz and Stefan.
Yes, Stefan, thanks for being awake at 3 a.m.
All good.
All right. Cheers.
Bye, everyone.
Thanks, Dave. See ya.
Recording stopped.